By far the most viewed video on this channel is the one where I tried to figure out what Pangaea would have looked like 200 million years ago based on my understanding of ocean currents, climatology, and general Earth science. Ever since making that video, people have been asking for a follow-up where I look in equal time span into the future to see what will become of this planet. Though to be honest, I've resisted making this video, as to me, it's one thing to use geologic evidence to piece together what the past looked like. That's scientific. It's another thing to try to predict what will happen in the future. That's just speculation. So I was never really interested in answering this side of the question. But recently I've come to realize that making predictions is also part of the scientific process. Whether it's predicting where lost islands would have been, predicting where unexpected rainforests might grow, or predicting what Mars may have once looked like. It turns out trying to guess the outcome of an experiment is actually an important step in finding something new. So let's finally do it. Let's see what more we can learn about this planet today by trying to figure out what the Earth will look like 200 million years in the future. Okay, so the first step in figuring this all out is finding a source I can actually trust to tell me what will happen in the future. As it stands currently, there's only one man on this planet I trust for this, Christopher Scotes. I know this name doesn't mean much to most of you, but trust me, if you're a fan of this channel or any others like it, chances are you've seen Professor Scotes' work. It was Chris who made the maps behind this animation that you've watched in numerous videos of mine. You might have even noticed my messages thanking Chris at the ends of my videos.
The vast power of the computer has allowed Christopher Scotes of the University of Texas to reconstruct whole chapters of Earth's intriguing past.
My work is really a fulfillment of a childhood fantasy to invent a time machine and travel back in time. In effect, that's really what we're doing here, using interactive graphics to take a peek back into time and see what the continents and oceans were doing millions of years ago. It's really like a second voyage of Columbus, but this time it's a voyage in time and not a voyage in space.
Long story short, Christopher Scotes has dedicated his life to understanding and visualizing the movements of Earth's plates, and as a result has produced the most comprehensive recreations of its paleogeography on the internet, the only ones I trust enough to use in my own videos. Fortunately, Christopher is just as curious as you all, and as soon as he figured out the general mechanics of plate tectonics over the past 200 million years, Chris applied what he'd learned to see if he could predict what the Earth might look like over 200 million years from now, based on how it's been moving. Doing this, Chris discovered something so new that it hasn't even happened yet. In approximately 250 million years, the continents will collide with one another once again, forming back into a single supercontinent, a place Scotes has labeled as Pangaea Proxima. That's right, even though you might have already heard about it through other pop geography content, I promise you this idea originated with Christopher Scotes, as he published his findings for everyone to read in this presentation, titled The Atlas of Future Plate Tectonic Reconstructions. And this is where I'll be sourcing the bulk of information for this video, as it comes from the only person I trust to tell me what'll happen millions of years from now. Here, Chris moves forward in 25 million year increments, giving us an idea of not only the final product, but also all of the movements it took to get here as well. So let's dive in and start with the very first frame, showing us the geography of modern day. In a lot of ways, this is the most informative map in the whole series, as it's only from our understanding of the Earth at this moment that we can extrapolate all the rest of these maps. Here we can see arrows indicating the direction of each tectonic plate. Along the mid-Atlantic ridge, the arrows point away, telling us this is a divergent plate boundary. This pushing of the ocean floor in turn forces the entire continent of Africa in a northeastern direction, indicated by this arrow. The Pacific Ocean also appears to be expanding along its ridges, forcing plates to converge and subduct under one another, building mountains like the Andes and Rockies. Around the other side of the planet, a rift in the Indian Ocean also appears to be driving the Australian plate northward, represented by this arrow. Overall, these are the general tensions that currently exist between the plates of this planet and will be the driving forces for change in the years to come. Although it might not seem like a lot of information to go off of, it's virtually all we have at our disposal to predict where things will go from here. Though to see how these tensions begin to resolve themselves, we must take our first step 25 million years into the future. Okay, I know not that much appears to have changed, but actually 2 important collisions have already taken place. First, Africa has smashed into Arabia, fully joining the Asian landmass and closing the Red Sea, with the material between these lands being thrust up into a new mountain range at the center of Afro-Eurasia. The second great collision happened over here, as the Australian plate is pushed against the Sunda Plateau, part of Asia's continental shelf, bringing the Australian landmass into contact with the islands of Southeast Asia, but not quite mainland Asia yet. For the most part, however, the world would still be recognizable. Jumping another 25 million years into the future, we'll find these processes have progressed even further. Africa has continued its movement north, crashing into southern Europe and closing the Mediterranean Sea, forming the truest version of Afro-Eurasia. Meanwhile, Australia has also continued its way north, sliding against the Sunda Plateau, converging into East Asia, causing a new mountain-building event to take place between them. These mountains would bridge the gap between mainland Asia and Australia for the first time, forming the megacontinent of Austro-Afro-Eurasia. The Americas, by contrast, remain basically the same as they are now, just a little bit more crunched together. Stepping another 25 million years into the future, Africa is now pressed firmly against Eurasia, forming a series of mountain chains all along this fused boundary. This in turn would produce some significant internal divisions within this landmass. Although this isn't that notable now, trust me, once we get to predicting climate and biomes, it'll have an effect. On the other side of the world, Australia proper has finally crashed into mainland Asia, lifting all of what's now China up into another massive mountain chain that'll only continue to grow as these movements persist. Though together, all this pushing against Asia would force it to budge up against the North American plate, causing some moderate uplift where the Bering Strait once was, joining Austral-Afro-Eurasia to the Americas. Technically, the result of this would be a partial Pangaea, or a Pangaea partialis if you will, as 6 of the 7 traditional continents have now merged, with only, Antarctica left out. So far, very little has happened on this continent, but it's thought that in another 25 million years, the planet will enter a greenhouse climate, causing much of its ice to melt, exposing the actual lands of Antarctica to be a collection of islands. This melting would cause worldwide sea levels to rise, flooding substantial areas, most notably the Bering Land Bridge that just recently formed, breaking this Pangaea partialis back into 3 major landmasses: America, Austro-Afro-Eurasia, and Antarctica, which has now started splitting in 2. Another time jump ahead, and now we're a total of 125 million years in the future. The biggest development here is this new rift opening up between the Eurasian plate and the North American plate, driving them apart once and for all, with the Americas taking the Chukchi Peninsula with them as an associated archipelago. However, as these continents are pushed away from each other on one side of the planet, this translates to them being pushed towards each other on the opposite side of the planet. Meanwhile, the continued pressure of Africa and Australia pushing against Eurasia has now built up a series of mountains as tall as the Himalayas throughout the continent's interior. To the south, another ocean ridge continues breaking Antarctica apart, driving the majority of it north towards India. Stepping forward in time again, and the Antarctic landmass collides with the Asian continental shelf for the first time, building a series of highly chaotic islands just to its south. This Antarctic archipelago will also begin to enclose the Indian Ocean, turning it into another internal sea, kind of like a new Mediterranean Sea, only this one sits right along the equator and opens up to the south, which again isn't that important now, but will affect the continent's climate and things later on. Another step forward, and all these trends have continued. Most notably, the rift in the Pacific is still expanding, driving the Americas in the direction of Africa, causing the Atlantic Ocean to begin closing up. One more step forward, and we're now a full 200 million years in the future. The sustained expansion of the Pacific Ocean has forced the Americas in close proximity to Afro-Eurasia, with the Atlantic now just a fraction of its former size. Yet another step ahead, and we arrive at what might be the most dynamic period in this whole process. The Grand Banks of North America have just started smashing into West Africa, sealing up the Atlantic Ocean on the side, while South America has just begun to collide with the very bottom of Africa, bringing both of the Americas into contact with Africa at two different points. This will effectively enclose the Atlantic Ocean into another internal seaway, which is actually pretty cool, and there are some really interesting implications of a world like this. However, there's one last frame in this animation, bringing us a full 250 million years from now. Any further into the future, and it's basically impossible to know what will happen, so this is where we'll end our time-traveling adventure. As we can see, every major landmass on the planet has come together once again, forming what Christopher Scotese calls Pangaea Proxima, which I guess is a better name than Ant-Austro-Afro-Eurasia-America. North America has now fully collided with Africa, leaving only two small basins between them where the Gulf of Mexico and Gulf of Maine used to be, what would no doubt be the continent's deepest lakes. Though the most notable feature of this Pangaea Proxima is surely the internal sea, what I'm calling the Mediterranean Sea, which gives some depth to an otherwise shapeless blob of land. Ironically, the landmass of Pangaea Proxima resembles the original Pangaea in a lot of ways, which I guess makes sense considering they're composed of the same exact geologic units, just in a slightly different arrangement. Now I hope you can see why I wasn't very interested in making this video, as it's pretty much the same thing as before. But alright, we've finally figured out the geography of the future, so now comes the fun part. Applying principles of Earth science to this map to see what it will look like in terms of surface vegetation. Currently, all this map shows us is elevation, which is certainly helpful, but I want an idea of its natural environments as well. So just like before, we need to start at the beginning, wind direction. Considering the Earth will still probably be spinning in the same direction, we can assume the same basic logic in airflow across its surface. This allows us to begin figuring out ocean currents. From here, warm equatorial waters would blow all the way westward across the Pacific until they ran into the eastern shores of Pangaea Proxima, roughly where Japan used to be. This would force the current to split in two, with one stream going north over the top of Asia and another going south down around Australia. At these latitudes, winds would cause the water to circle back around the poles, where it would cool down before landing on the other side of the ocean. From here, the cold water would travel down the coast of what was once California and up South America, warming up in the process before meeting at the equator and getting sent back out to sea, completing the Great Pacific Ocean Gyre. Lastly, we can also throw in some circumpolar currents, and that finishes the basic scheme of Earth's future ocean circulation system. And I know what you're wondering, one big loop, is it really that simple? And the answer is yes. It turns out that's just what you get when all the world's continents recombine. There's far fewer obstacles for water to navigate around, so you end up with a very simplified system of ocean currents. Though there is one last area ocean waters would flow, the Mediterranean Sea. The only way for water to enter this basin would be through the southern opening, where cold polar waters would pour in. Moving northward, however, the water would begin to warm up until it reached the equator, where it would have nowhere left to go. This at last completes our model of Earth's future ocean currents. And now that we have this, we can finally start predicting the environments of Pangaea Proxima. As we learned previously, lands beside warm currents receive lots of moisture, so they tend to be forested and lush, whereas lands beside cold water currents tend to be dry, resulting in deserts. Applying this logic to Pangaea Proxima, we can see the most consistent place for warm water to be delivered to will be the East Coast, along what was once Northern Asia and Australia. As a result, these lands will likely become home to expansive forests, reaching as far inland as the mountains will permit. Although we just watched these form, they'd now be some of the tallest mountains on the planet and would prevent this moisture from reaching any further into the continent. Beyond this point, however, the waters would cool off and enter the circumpolar current, bringing cold water into contact with the entirety of the supercontinent's northern and southern shores. This would produce vast deserts across the interior of this landmass, including one spanning almost the entirety of Africa and North America. As this water flowed south against Proxima's western side, it would warm back up, potentially bringing some moisture to its equatorial region. But once again, tall, freshly built mountains would block most of this water from reaching any further into the interior, leaving only a narrow green belt along the supercontinent's west coast. That leaves only the Mediterranean Sea. Despite cold water flowing in from the south, its position at the equator would inevitably cause the water to warm up and evaporate. Prevailing winds would blow this moist air westward, delivering a moderate degree of moisture to these internal lands. But again, the great mountain ranges formed from Africa's many collisions would mostly contain this rain, leaving a great green center surrounded by deserts. Overall, the picture of Pangaea Proxima that's emerging is one of a vast desert land, with only the occasional and isolated oasis for life. While the isolation of these forests does kind of interest me, what I find even more interesting is how this is pretty much the same thing we found after looking at the OG Pangaea. Both seem like they would have been rather arid places, with life clinging on only around the peripheries. Although that might not sound very groundbreaking, this is actually the important takeaway from all this. Moisture can only reach so far onto a landmass before it runs out, so the larger a landmass is, the more dry it'll be. It was only after realizing this that I decided this video was worth making, as this thinking has given me a newfound appreciation for the geography of the modern world. It appears this planet's geography flips between two possible states. On one side, a Pangaea, or in Greek, an all-land, in which every major geologic unit is combined together, producing a vast desert land with one large mixed gene pool. On the other side of the spectrum is what I'm calling a Panacea, or all islands, the kind of world we live in now, where the major cratons have all separated from one another, leaving a collection of more isolated but wetter continents. And I'd like for us all to just appreciate that for a second. Instead of living on one amorphous desert continent, we got to live in and study a world with several different lands, each with their own special characteristics and distinct collections of life, each one receiving more rainfall separately than they would together. Based on these thought experiments, it appears a Panacean world is the more conducive to life, as it both allows for water to reach continental interiors and isolates populations from one another, causing them to evolve apart in some really fascinating ways. Whereas Pangaeas always become dry and homogeneous. It was only by seeing what both the past and the future held that I was able to gain a new perspective on our current geography, and now more than ever, I'm grateful that I got to explore this Earth during its most dynamic time, when even the continents are islands. Hey everyone, with the holidays just around the corner, I'd like to remind you all that I still have a few prints of this poster and this map up for sale on my store right now. If you or someone you know has expressed interest in these, now would be a great time to pick one up. I'd also like to remind you that just recently I launched a second channel called Archive Dive, where I watch old archival documentaries in their entirety. So if you're home for the holidays in need of something to keep you entertained, give Archive Dive a try. One last thing before we go, I'd like to give a huge final thank you to Christopher Scotese, not only for the hard work he did in researching all this, but also for making these resources available for others. In fact, Chris operates his own YouTube channel where he uploads these map animations in closer detail, so if this video hasn't quite scratched the tectonic itch, you know where to head after this. Besides that, thank you all for watching, and I'll see you all again very soon.
I think one of the most important things we're learning by going through this exercise is that plate tectonics is a global process, and it affects a variety of other global processes, such as climatology, mountain building, and possibly even evolution.